You are sitting completely still, staring at a screen, maybe drinking coffee or just relaxing, but right in this very second, while you take a single breath, you have hurtled through cosmic space across a distance of dozens of miles. Your room, your house, our entire planet is flying through the icy void at an insane speed along a completely unpredictable trajectory. Our movement is not a neat circle around a star like they drew in textbooks, but an endless wild spiral. We never, not for a single millisecond, return to the point in space where we were a moment ago. We are flying into the unknown, and where our Earth is heading is far stranger and more terrifying than you can possibly imagine. If you want to uncover the deepest secrets of the cosmos and understand our true place in the universe, consider subscribing to the channel. And now, let's begin our journey. Look at a photograph of the night sky taken with a long exposure camera. This is a completely real picture that anyone can take if they leave a camera on a tripod for a few hours on a clear, dark night. In this photograph, the stars do not look like dots. They leave long, bright, glowing arcs that perfectly curl around one central point in the sky, the North Star. This beautiful optical effect is perhaps the only visual and undeniable proof that right now we are on the surface of a giant stone sphere that is endlessly spinning on its axis. The stars are not moving anywhere in this moment. It is us spinning beneath them, like on a colossal merry-go-round torn from its foundation. We do not feel this rotation. We do not hear the deafening whistle of the wind from the fact that the Earth's surface at the equator is rushing at a speed of over 1,000 miles per hour. That is faster than the speed of sound. If you stood on the equator and could fly next to the Earth without touching it, you would need a supersonic fighter jet just to stay in one place relative to the surface. But to us, everything around looks completely static. The water in a glass does not splash, birds fly freely in any direction, and clouds lazily drift across the sky. This illusion of absolute rest has deceived the greatest minds of humanity for centuries, making them believe that the Earth is the motionless center of the entire universe. The secret of this deception lies in the greatest discovery science has ever made, the principle of relativity, first formulated by Galileo Galilei. Our brain, our vestibular system, and our senses are not evolutionarily designed to feel speed itself. We only feel acceleration or deceleration. When you are flying in a passenger jet at an altitude of 30,000 feet, at a speed of 500 miles per hour, you can calmly pour water into a plastic cup and it will not spill. The air inside the cabin, your body, the cup itself, and the water in it, everything is moving at the exact same speed. The exact same thing happens with our planet. The Earth's crust, the oceans, the atmosphere up to the very highest layers, and all of us move together as a single unit. Gravity permanently ties us to this spaceship, and the constant speed of rotation prevents our senses from sounding the alarm. But spinning on its axis is not even the first level of the insane nesting doll of speeds we find ourselves in. While the Earth spins like a top, it simultaneously flies along a giant elliptical orbit around the Sun. To manage to make one full revolution in 365 days, our planet must move at a colossal speed of 67,000 miles per hour. That is roughly 18 miles every single second. In the time it took you to blink, the Earth, along with you, moved through space a distance greater than the length of an average city. We cut through the vacuum of the solar system like a bullet fired from a massive gun, its trajectory bent by the crushing weight of the gravitational field of our home star. Here lies another massive illusion that most people believe. If you close your eyes and try to visualize the solar system, you will most likely imagine a big yellow sun hanging motionless in the center of a black void, and planets obediently cutting even circles around it. This heliocentric model is hammered into our heads from early childhood, and it is fundamentally catastrophically wrong in the context of reality. The sun does not hang in place. It is never at rest for a single second. Our star is an active, incredibly fast object that is itself flying through interstellar space, and it flies at a terrifying speed of about 514,000 miles per hour. When scientists first realized this fact, the old comfortable picture of the world finally collapsed. The Earth does not simply revolve around the Sun in a closed circle. Because the Sun is constantly flying forward, our planet is forced to chase after it, leaving behind an incredibly complex trajectory in the form of an elongated spiral. Think of a spring stretched to infinity. The Sun flies in a straight line, like the central rod of this spring, and the Earth and all the other planets wind circles around this flying axis. We are like moths desperately circling a lantern mounted on the nose of a high-speed train rushing through the night. This spiral means one very simple but profound thing. Every moment of your life, every birthday, every holiday, the Earth is in a completely new place in the universe. We fly through cosmic clouds of gas, through regions of emptiness, through territories where nothing has existed for billions of years. The area of space we were in yesterday has been left behind by millions of miles, and we will never, ever return there. Our solar system is a flying swarm of planets, asteroids, comets, and dust, united only by the gravitational grip of our mother star. But where exactly is our sun flying? This movement is not random. The great astronomer William Herschel first understood this back in the late 18th century. He spent long nights at his telescope, meticulously sketching the positions of bright stars. Herschel noticed an amazing oddity. The stars in the constellation of Hercules seemed to slowly, very slowly, drift apart in different directions, like trees in a forest when you walk directly toward them. At the same time, the stars on the opposite side of the sky, in the constellation of Columba, seem to be getting closer together, like trees behind you when you walk away. This is an optical phenomenon that occurs in only one case, if the observer themselves is moving. Herschel made a bold and absolutely correct conclusion. Our solar system is flying toward a specific point in the starry sky, right toward the constellation of Hercules. Astronomers called this invisible destination the solar apex. Right now, while you are listening to these words, you are flying toward a star called Vega at a speed of 45,000 miles per hour relative to our closest neighboring star systems. This is our movement inside our local bubble of interstellar gas, the so-called local interstellar cloud. But even this cloud, and Vega, and Hercules, and our Sun itself, we are all locked into a much grander structure. We are inside the Milky Way. Our galaxy is a disk of monstrous proportions, consisting of hundreds of billions of stars, untold clouds of dust, and dark matter. And this disk is rotating. The solar system is not located in the center, and not on the very edge, but somewhere halfway to the outskirts, in one of the spiral arms called the Orion Arm. The enormous mass of the entire galaxy, especially the supermassive black hole at its center and the dense cluster of stars around it, creates a gravitational field of unimaginable power. This field pulls us toward itself, but the immense speed of our movement throws us along a tangent, forcing us to orbit around the galactic core. The speed of our flight around the center of the Milky Way goes beyond the limits of intuitive understanding. We are rushing along our orbit at a speed of about 514,000 miles per hour. Even at such a crazy speed, it takes our system 230 million Earth years to complete just one full revolution around the center of the galaxy. Astronomers call this giant stretch of time a galactic year. Think about it. One galactic year ago, when the solar system was last at this exact theoretical point in its galactic orbit, the very first, most primitive dinosaurs were just beginning to appear on our planet. There were no mammals, no birds, and certainly no humans. The Earth looked like a completely different alien world, and 2 galactic years ago the first vertebrate animals were just beginning to appear on land. The entire history of humanity, from the appearance of the first stone tools to the creation of the internet, is just an insignificant, invisible fraction of 1% of this great cosmic year. But this movement around the center of the galaxy does not happen on a smooth and even road. The Milky Way has thickness. The galactic disk is not an absolutely flat sheet of paper. As the Sun, along with its planets, flies along its giant circular orbit, it also makes wave-like movements up and down, crossing the galactic plane like a dolphin swimming at the surface of the ocean, sometimes breaching the surface, sometimes diving underwater. One such cycle of diving and surfacing takes tens of millions of years. Some scientists link these crossings of the dense dust equators of the galaxy with mass extinctions on Earth, when gravitational disturbances brought down storms of comets and asteroids onto our planet. Our journey harbors hidden rhythms and dangers that we are only beginning to guess at. Furthermore, the plane of rotation of the solar system itself, in which the orbits of all our planets lie, is heavily tilted relative to the plane of the Milky Way. The angle of this tilt is approximately 60 degrees. This means that we are flying through the galaxy literally sideways. The Earth, the Sun, and all the other planets rush through space like a tilted umbrella held up against a cosmic wind. We push through the rarefied interstellar gas, and our magnetic field deflects streams of charged particles, creating a protective bubble around the entire system, the heliosphere. We fly through a hostile environment at enormous speed, protected only by invisible physical fields. And if you are impressed by the speeds inside our galaxy, then get ready for what happens outside of it. Because the Milky Way, with all its hundreds of billions of stars, is also far from a stationary object. It is just a speck of dust against the backdrop of even larger structures in the universe, and this speck of dust is also in a state of free fall toward its inevitable fate. We live in a small cosmic village that astronomers call the local group of galaxies. This group includes the Milky Way, the massive Andromeda Galaxy, the Triangulum Galaxy, and about 50 smaller dwarf galaxies that circle around their larger siblings like moons around planets. And in this local group, a drama of epic proportions is playing out. Our closest major neighbor, the Andromeda Galaxy, is not just hanging somewhere out there in the abyss at a distance of 2.5 million light-years. It is flying, and it is flying straight at us. Because of colossal mutual gravitational attraction, the Milky Way and Andromeda are inevitably approaching each other at a speed of about 250,000 miles per hour. Every single second while you breathe, this giant stellar spiral gets 68 miles closer to our planet. On the scale of the universe, this movement is equivalent to firing 2 cosmic shotguns at each other. Eventually, in about 4.5 billion years, these 2 colossal galactic titans will collide. But this collision will not be like a car crash. Galaxies are mostly empty space. The stars within them are separated by such unimaginable distances that physical collisions between individual stars will be incredibly rare. Instead, it will be a majestic gravitational dance. The 2 galaxies will pass through each other, their gravitational fields ripping apart spiral arms and tearing streams of stars into intergalactic space. Over hundreds of millions of years, they will swing back and forth, eventually merging into one single gigantic elliptical galaxy, which astronomers have already named Milkomeda. If humanity or our distant descendants are still around to see it, the night sky will be a blazing canvas of billions of new stars, a sight more spectacular than anything we can witness today. But even this monumental collision is just a local event, a minor traffic accident in a quiet cosmic suburb. Because while we are falling toward Andromeda, the entire universe is doing something completely counterintuitive. It is expanding, and it is not just expanding, it is expanding at an accelerating rate. This is the realm of dark energy, a mysterious invisible force that makes up nearly 70% of the universe. Dark energy is stretching the very fabric of space and time, pushing galaxies away from each other. If you look at galaxies outside our local group, they are all flying away from us. The further away they are, the faster they are receding. This expansion was first discovered by Edwin Hubble nearly 100 years ago, and it completely changed our understanding of the cosmos. So we have a cosmic tug-of-war happening right now. Gravity is trying to pull everything together, which is why Andromeda is falling toward us. But on a much larger scale, dark energy is tearing the universe apart. Within our local group, gravity is winning. Our local neighborhood is tightly bound enough to resist the expansion of space. But look beyond our borders, and dark energy reigns supreme. The empty space between galaxy clusters is growing, making the universe a colder, darker, and more isolated place with every passing second. But wait, our journey is far from over. We must zoom out even further. Our local group is not wandering alone in the void. We are located on the very edge of a much larger structure called the Virgo supercluster. This is a massive collection of galaxy groups and clusters, containing tens of thousands of galaxies, all bound together by a complex web of dark matter. The center of this supercluster is the Virgo cluster, a massive gravitational anchor located about 65 million light-years away from us. And guess what? We are moving toward it. The immense mass of the Virgo cluster is pulling our entire local group, along with Andromeda and all our dwarf galaxies, toward its center at a speed of about 400,000 miles per hour. We are caught in a gravitational river, flowing toward an unseen ocean. Yet, even the mighty Virgo supercluster is just a tributary in a much larger cosmic river. In the 1970s, astronomers mapping the cosmic microwave background, the fading afterglow of the Big Bang itself, noticed something highly unusual. One side of the sky was slightly warmer than the other. This temperature difference was minuscule, but it indicated a profound and terrifying truth. Our entire Milky Way galaxy, our local group, and indeed the entire Virgo supercluster were moving together through the universe at a mind-boggling speed of 1.3 million miles per hour. But what is pulling us? What could possibly have enough mass to drag tens of thousands of galaxies across millions of light-years of space? Astronomers looked in the direction of our massive movement and found nothing, or rather, they couldn't see anything. The direction we are heading points straight through the densest part of our own Milky Way galaxy. Thick clouds of interstellar dust and gas block our view of the universe beyond, creating a blind spot in the sky known as the zone of avoidance. We are driving a cosmic car at over 1,000,000 miles an hour, and our windshield is completely smeared with mud exactly in the direction we are heading. For decades, this massive gravitational anomaly was simply called the Great Attractor. It sounded like something out of a science fiction movie, a terrifying unseen force dragging us into the dark. But with the advancement of radio and X-ray telescopes, which can pierce through the dense dust of our galaxy, the mystery slowly began to unravel. The Great Attractor is not a single supermassive black hole or an evil cosmic entity. It is a vast region of space containing an unimaginably dense concentration of mass, equivalent to tens of thousands of Milky Way galaxies. It is the gravitational focal point of our local universe. But the story does not end there. In 2014, a team of pioneering astronomers mapped the complex motions of thousands of galaxies in our cosmic neighborhood. They didn't just look at where galaxies were, they looked at where they were going. By tracking the cosmic rivers of galactic movement, they realized that the Great Attractor is just the central hub of an even more colossal structure. They had mapped out our home supercluster, a majestic web of galaxies spanning 500 million light-years across. They named it Laniakea, which means immense heaven in the Hawaiian language. Laniakea looks exactly like a vast cosmic neural network or a massive branching river system. Within Laniakea, there are an estimated 100,000 galaxies, including our own, and every single one of them is flowing along invisible streams of gravity, drawn toward the massive valleys of Laniakea's gravitational landscape. We are just one tiny drop of water in this immense heavenly river. We are flowing away from an expansive cosmic void called the local void, being pushed by its sheer emptiness and pulled by the dense mass of the Great Attractor and the even larger Shapley supercluster located far beyond it. Our trajectory is not a simple straight line, but a complex, winding path through the invisible gravitational hills and valleys of the local universe. But the story of our cosmic trajectory does not end with Laniakea and the Great Attractor. In fact, it gets even more bizarre. For decades, astronomers assumed that the only significant force driving the movement of galaxies across the universe was the gravitational pull of massive structures. It makes logical sense. Gravity is the ultimate cosmic glue, pulling matter together into denser and denser clumps. So if we are moving at over 1,000,000 miles per hour in a specific direction, it must be because something incredibly massive is reeling us in. However, in 2017, a team of researchers looking deep into the map of the local universe discovered that the gravitational pull of the Great Attractor and the Shapley supercluster only accounts for about half of our velocity. The math simply did not add up. There was a missing force, an invisible hand pushing us from behind. To understand this, we have to flip our perspective on how gravity works on a cosmic scale. Gravity does not just pull things toward mass, it also means things fall away from emptiness. Imagine you are standing on a perfectly flat sheet of rubber and someone places a heavy bowling ball a few feet to your left. The rubber sheet bends, and you naturally slide down the slope toward the ball. This is how the Great Attractor works. But now, imagine someone else comes along and pushes their hand up from underneath the rubber sheet, creating a large smooth hill just to your right. You will slide down that hill, away from the elevated area, and your speed toward the bowling ball will double. You are being pulled by the depression and pushed by the elevation. In the real universe, that invisible hill is a colossal, mind-bending region of nothingness. Astronomers named it the dipole repeller. It is an immense cosmic void, an area of space so vast and so spectacularly empty that it is practically devoid of galaxies, stars, gas, and dark matter. Because this region lacks mass, it also lacks gravitational pull. The areas surrounding this void, which are filled with galaxies and matter, possess a much stronger gravitational grip. Therefore, matter naturally flows away from the void, seeking the higher density of superclusters. We are literally being repelled by nothingness. We are fleeing from a ghost. This gargantuan expanse of emptiness is pushing our entire galactic neighborhood, adding hundreds of thousands of miles per hour to our total velocity. The realization that cosmic voids act as active repellers completely changed our understanding of the universe's architecture. The cosmos is not just a collection of galaxy clusters, it is a sprawling sponge-like web. The dense, glowing filaments of this web, where galaxies string together like pearls on a spider's thread, are constantly drawing matter away from the vast, dark, silent voids that make up the spaces in between. And our Milky Way happens to be surfing exactly on the boundary between these two extremes. We are being ejected from the local void, pushed outward by the terrifying emptiness of the dipole repeller, and simultaneously dragged toward the dense, chaotic heart of the Shapley supercluster. This brings up a fascinating and somewhat unsettling question. With all these overlapping vectors of movement, the Earth spinning, the Earth orbiting the Sun hurtling through the Milky Way falling toward Andromeda, and our entire local group rushing through the Laniakea supercluster, pushed by voids and pulled by attractors, is there any final, absolute speed? Are we moving relative to something that is completely, unconditionally still? For a long time, physicists, including Albert Einstein, debated whether such a thing as a universal background or an absolute frame of reference even existed. Einstein's theory of relativity famously states that all motion is relative. You can only measure your speed compared to another object. A car moving at 60 miles per hour is doing so relative to the asphalt. A plane moves relative to the air and the ground. But does the universe itself have an asphalt road? Does space have a stationary grid against which we can measure our ultimate cosmic speedometer? Astonishingly, the answer is yes. And this ultimate stationary grid is not made of matter, but of ancient fossilized light. It is called the cosmic microwave background radiation, or CMB for short. To understand what this is, we have to look back to the very dawn of time, approximately 13.8 billion years ago, to the immediate aftermath of the Big Bang. In its infancy, the universe was not a cold, dark place with scattered stars. It was an infinitely dense, unimaginably hot ocean of glowing plasma. There were no galaxies, no stars, no atoms, just a seething soup of subatomic particles and intense radiation. As the universe expanded, it began to cool down. About 380,000 years after the Big Bang, the temperature dropped just enough for the first complete atoms of hydrogen and helium to form. In that exact moment, the thick, glowing fog of plasma cleared. The universe suddenly became transparent, and light was finally able to travel freely through space. That very first burst of light, the afterglow of the universe's fiery birth, has been traveling through space ever since, for over 13 billion years. Because the universe has been constantly expanding all this time, the wavelengths of that ancient light have been stretched out. What started as intensely hot gamma radiation has been cooled and stretched so much that it is now invisible to our eyes, existing in the form of faint microwaves. If you could see microwave radiation, the entire night sky would not be dark. It would be glowing with a uniform, incredibly faint light, coming from every single direction at once. It is the oldest light in existence, the wallpaper of the cosmos. Its temperature is just a fraction of a degree above absolute zero, about 2.7 degrees Kelvin. This cosmic microwave background provides the ultimate universal frame of reference. It is the closest thing to absolute stillness that exists in nature. If you were a completely stationary observer in the universe, not pulled by any galaxy or pushed by any void, this ancient microwave glow would look exactly the same in every single direction. It would be a perfectly uniform sphere of temperature around you. But when astronomers pointed their most sensitive microwave telescopes at the sky, they did not see a perfectly uniform glow. They saw something that perfectly confirmed our incredibly complex high-speed journey. They saw a cosmic dipole. When we look in one specific direction of the sky, toward the constellation of Leo, the cosmic microwave background appears ever so slightly hotter or more compressed. When we look in the exact opposite direction, toward the constellation of Aquarius, the background radiation appears slightly cooler or more stretched out. This temperature difference is incredibly small, just a few thousandths of a degree, but it is undeniably there. This is the ultimate cosmic speedometer in action. It is the exact same principle as a police radar gun, or the Doppler effect you hear when an ambulance drives by. When an ambulance speeds toward you, the sound waves of its siren are compressed, making the pitch sound higher. When it speeds away, the sound waves are stretched, making the pitch sound lower. Light works the exact same way, because our entire solar system, along with the Milky Way and our local group of galaxies, is hurtling through space in a specific direction. We are literally driving into the ancient light of the Big Bang. The microwave radiation ahead of us is compressed, shifting to a slightly higher frequency and appearing warmer. The radiation behind us is stretched, shifting to a lower frequency and appearing cooler. By measuring this exact temperature difference, astrophysicists were finally able to calculate our absolute, true speed through the universe. When you add up the Earth's orbit, the Sun's flight, the galaxy's rotation, and the gravitational tug-of-war of the superclusters. Our final absolute velocity relative to the very fabric of the cosmos is approximately 1.3 million miles per hour. Let that number sink in. 1.3 million miles per hour. Every single hour of your life, you are moving further than the entire circumference of the Earth 50 times over. While you watched a standard movie, you traveled over 2.5 million miles across the universe. You are an astronaut on a generational starship that is breaking every speed limit imaginable, and you do not even need to wear a spacesuit. This staggering realization brings with it a whole new set of profound, almost philosophical consequences. For one, if we are moving this fast, how does it affect time? According to Einstein's theory of special relativity, time is not a constant ticking clock that is the same for everyone everywhere. Time is flexible, and it is intimately connected to speed. The faster you move through space, the slower you move through time relative to a stationary observer. This phenomenon is known as time dilation. Because we are hurtling through the universe at over 1 million miles per hour, our clocks on Earth are ticking ever so slightly slower than the clocks of a hypothetical, completely stationary alien civilization. The effect is minuscule, altering our perception of time by mere fractions of a second over millions of years, but the physics are absolute. The sheer kinetic energy of our planetary spaceship is literally bending the flow of time around us. We are all, in a very real, scientifically proven sense, time travelers, constantly slipping a microscopic fraction of a second into the future compared to the rest of the stationary cosmos. But with all this terrifying breakneck speed, with galaxies flying at each other like cosmic shrapnel and superclusters dragging thousands of star systems through the dark, why does the night sky look so peaceful? Why don't we feel a sense of impending doom? The answer lies in the second most terrifying aspect of our universe, its sheer incomprehensible scale. The distances between things in space are so vast that they defy human logic. Even though Andromeda is rushing toward us at 250,000 miles per hour, it will still take 4.5 billion years to reach us. To put that into perspective, our entire solar system is only about 4.5 billion years old. Andromeda is so far away that its light, traveling at the absolute speed limit of the universe, takes 2.5 million years to reach your eyes. When you look at the Andromeda galaxy through a telescope tonight, you are not seeing it as it is now. You are seeing it as it was 2.5 million years ago, before modern humans even walked the Earth. Our minds simply cannot grasp a void that deep. Our cosmic journey is a lonely one. Despite our incredible speed, we will likely never pass close enough to another star system to see its planets with the naked eye. The space between stars is so unfathomably huge that when the Milky Way and Andromeda eventually do collide, the billions of stars within them will pass right through each other like ghosts. The chances of two individual stars physically crashing into each other during a galactic merger are practically zero. We are speeding down a highway that is millions of miles wide, and we are the only car on the road, and this isolation is only going to get worse. While we are caught in the local currents of gravity, rushing toward the great attractor, the universe itself is doing something entirely different on the grandest scales. Remember that mysterious dark energy we talked about? The force that is stretching the fabric of space itself? This is where the ultimate bizarre fate of our journey reveals itself. Right now, gravity is strong enough to hold our local group together. It is strong enough to pull us toward the Virgo cluster and the great attractor, but dark energy is relentless, and its power increases with distance. The further away two objects are, the faster the space between them expands. While we are slowly making our way toward the heart of the Laniakea supercluster, the immense voids separating Laniakea from other superclusters are expanding at an accelerating rate. If you look far enough into the future, tens of billions of years from now, a terrifying picture emerges. The expansion of space driven by dark energy will eventually outpace the gravitational pull of the great attractor. The cosmic river we are currently swimming in will dry up. Laniakea, this majestic branching structure of 100,000 galaxies, will be torn apart. The distant clusters that we are currently being pulled toward will be swept away by the expanding tide of space, receding from us faster than the speed of light. They will cross the cosmic horizon, disappearing from our observable universe forever. Even the great attractor itself will eventually fade into the unapproachable distance, lost to the relentless stretching of the void. Our epic journey toward the center of the local universe will be violently interrupted by the stretching of the fabric of reality itself. We will never reach our destination. Instead, we will be left stranded in an increasingly lonely pocket of space. In the unimaginably distant future, perhaps 100 billion years from now, our local neighborhood will look completely different. The Milky Way and Andromeda will have long since merged into a giant, featureless elliptical galaxy. Our sun will have died, turning into a slowly cooling white dwarf, and the Earth, if it survived the sun's death throes, will be a frozen, lifeless rock. But the sky above that dead Earth will be truly terrifying, because dark energy will have pushed all other galaxy clusters so incredibly far away, their light will never be able to reach us. The night sky will be completely empty of other galaxies. There will be no Virgo cluster, no distant spirals, no glowing cosmic web. An astronomer living in that distant era, armed with the most powerful telescopes imaginable, would look out into the void and see absolutely nothing but the stars of their own galaxy. They would have no way of knowing that the universe was once a bustling, crowded place, filled with billions of dancing galaxies. They would have no way of discovering the cosmic microwave background, as it would be stretched entirely beyond detection. They would logically conclude that their single, lonely galaxy was the entire universe, floating motionless in an eternal, static void. But let us pull ourselves back from that terrifyingly distant, dark future. Let us return to the present moment, to the here and now of our cosmic journey. When you try to hold all of this in your head at once, the Earth spinning, the solar system spiraling, the galaxy hurtling, the local group plunging toward the great attractor, and the very fabric of space expanding, it is easy to feel small, insignificant, and completely lost. It is incredibly tempting to ask one simple, logical question. Where is the center of all this movement? If the universe is expanding, where is the point of origin? Where is the exact center of the universe? The answer is one of the most mind-bending concepts in all of astrophysics. There is no center, or to be more precise, everywhere is the center. Because space itself is expanding, every single point in the universe looks like it is the exact center of the expansion. Imagine you are a raisin baking inside a giant loaf of raisin bread. As the dough rises and expands in the oven, every single raisin moves away from every other raisin. From the perspective of any one raisin, it looks like it is stationary in the center, while all the other raisins are rushing away from it in every direction. This is exactly what our galaxy experiences. If you were to magically teleport to a galaxy 5 billion light-years away, you would see the exact same thing we see here. You would see all other galaxies, including our Milky Way, rushing away from you. We are not moving through a pre-existing static box of space. Space itself is moving with us, stretching beneath our feet like a multidimensional cosmic treadmill made of pure nothingness. But how do we actually know this? How do we know these terrifying speeds are real? We cannot simply put a radar gun against the fabric of space. The secret to uncovering our true trajectory lies in a phenomenon called the Doppler effect, but applied to light instead of sound. You experience the Doppler effect every time an ambulance drives past you. As the siren approaches, the sound waves are compressed, making the pitch sound higher. As it drives away, the sound waves are stretched, making the pitch drop. Light behaves in the exact same way. When a star or a galaxy is moving toward us, the light waves it emits are physically compressed. This compression makes the light appear slightly more blue than it actually is. Astronomers call this a blue shift. When a massive object is moving away from us, its light waves are stretched out, making them appear slightly more red. This is known as a redshift. When astronomers point their massive telescopes at the Andromeda galaxy and analyze its light through a spectrograph, they do not see the standard spectrum of colors they expect from those types of stars. The entire spectrum of Andromeda is shifted toward the blue end. It is practically screaming at us through the language of physics that it is barreling in our direction. Conversely, when we look at almost every other galaxy outside our immediate local group, their light is shifted toward the red. The further away they are, the more radically red they appear. This was the monumental discovery made by Edwin Hubble in the 1920s. The redshift of distant galaxies is the definitive, undeniable proof that the universe is expanding and that dark energy is relentlessly pushing the cosmic fabric apart. Every single speed, every single trajectory we have discussed so far, from the frantic orbit of the Earth to our majestic plunge toward the great attractor, is calculated by meticulously dissecting the ancient light of distant stars, looking for those tiny telltale shifts in color. But there is a catch, a terrifying limitation to our ability to observe this movement. You might remember that Albert Einstein taught us that nothing can travel faster than the speed of light, 186,000 miles per second. That is the ultimate unbreakable speed limit of the physical universe. Yet we just established that distant galaxies are being pushed away from us by dark energy so fast that they will eventually disappear from our sky. How is that possible? Are they breaking the fundamental laws of physics? No. And this distinction is absolutely crucial to understanding the nature of our movement. The galaxies themselves are not moving through space faster than light. The space between the galaxies is what is stretching. Because empty space itself is not a physical object with mass, it does not have to obey the speed limit of light. It can expand as fast as it wants. And right now, the space at the very edges of our observable universe is expanding away from us faster than the speed of light. This creates a terrifying invisible boundary called the cosmic horizon. It is an incomprehensibly massive sphere surrounding our planet, extending about 46 billion light-years in every single direction. Beyond that sphere, the universe is still there. There are undoubtedly trillions of other galaxies, uncountable stars, exotic planets, and perhaps other intelligent eyes looking up at their own alien night skies. But we will never, ever see them. We can never interact with them. Even if we built a magical spaceship that could travel at exactly the speed of light, we could never reach those distant realms, because the empty space between us and them is stretching faster than our ship could ever fly. We are fundamentally and permanently cut off from the vast majority of our own universe, trapped in a localized bubble of visibility that is slowly but surely shrinking as dark energy accelerates the cosmic expansion. We are passengers on a ship whose windows are slowly being painted black from the outside. And yet, in the face of these crushing, godlike gravitational forces, incomprehensible speeds, and expanding voids, humanity has done something incredibly stubborn and remarkably beautiful. We have decided to join the race. We are not just passive passengers anymore. We have thrown our own tiny, fragile bottles into the roaring cosmic ocean. In the late 1970s, humanity launched two small robotic probes, Voyager 1 and Voyager 2. These machines, built with computers less powerful than a cheap modern digital watch, were hurled out of our solar system using the gravitational slingshots of Jupiter and Saturn. Today, Voyager 1 holds the title of the farthest human-made object in existence. It has officially pierced the heliosphere, leaving behind the protective magnetic bubble generated by our Sun, and is now sailing alone through the cold, dark, uncharted waters of interstellar space. And it is moving fast. It is flying away from Earth at a speed of about 38,000 miles per hour. By standard human metrics, that speed is absolutely mind-boggling. It is vastly faster than a rifle bullet. But let us compare it to the true scale of the cosmic machinery we have been exploring. Our entire solar system is orbiting the center of the Milky Way at 514,000 miles per hour. The Milky Way is falling toward Andromeda at 250,000 miles per hour, and our entire galactic neighborhood is rushing toward the Great Attractor at over 1,000,000 miles per hour. Against these titanic, sweeping cosmic currents, our fastest spacecraft is practically standing completely still. It is like a tiny, confused ant crawling on the floor of a bullet train that is simultaneously falling out of an airplane. Even at its incredible speed of 38,000 miles per hour, it will take Voyager 1 over 40,000 years just to pass relatively close to another star system. It would take it hundreds of millions of years to complete a single orbit around the Milky Way. Our most advanced, fastest technology is completely, hopelessly outmatched by the natural, effortless velocity of the very ground we stand on. We are moving at millions of miles an hour just by sitting on our couches, while our greatest rockets struggle to produce a fraction of that speed. This brutal realization brings us to one final, incredible consequence of our journey through the cosmos. It is the complete destruction of the concept of the present moment. Because we are moving across such vast distances, and because light takes time to travel across those distances, we are completely and irrevocably disconnected from the present moment of the rest of the universe. When you walk outside tonight and look up at the starry sky, you are not looking at space. You are literally looking at time. You are looking deep into the past. The light from our own moon takes about 1¼ seconds to cross the vacuum and reach your eyes. So, you never see the moon as it is right now. You see it as it was a little over a second ago. The light from the sun takes 8 long minutes to reach the Earth. If the sun were to magically extinguish and disappear right this exact second, we would not know about it for 8 full minutes. We would continue to orbit a ghost, bathed in phantom light, feeling its warmth, completely unaware of our impending doom. But as we look further out into the dark, the time delay becomes staggering. When you look at Sirius, the brightest star in the night sky, you are seeing it as it was 8.6 years ago. You are seeing the light that left that star back when you were younger. When you look at the stars in the magnificent Orion Nebula, you are seeing them as they were during the fall of the Roman Empire. And when you look at the Andromeda Galaxy, the titan that is currently rushing toward us to eventually consume our sky, you are seeing it as it was 2.5 million years ago. The Andromeda you see in your telescope does not exist anymore. The stars you see there might have already exploded into supernovas and died. Entire alien civilizations might have risen to incredible heights and completely fallen to ruin in the time it took that faint light to cross the intergalactic void. The universe we see above our heads is an illusion. It is a grand, shimmering mosaic of different eras, a beautiful patchwork of ghosts, stitched together by the agonizingly slow speed of light. Therefore, the actual present universe is completely invisible to us. We have absolutely no idea what the universe really looks like right now. By the time the light from the great attractor reaches our telescopes, hundreds of millions of years have already passed. The colossal structures pulling us through space might have already shifted their massive weight, evolved into different shapes, or been slowly torn apart by the relentless expansion of dark energy. We are driving down a pitch-black cosmic highway at over 1,000,000 miles an hour, navigating our ship by looking at a map that is millions of years out of date. It is a profound testament to the sheer power of human science, mathematics, and imagination that we are able to deduce our true dizzying trajectory at all, while flying completely blind through an ocean of ghosts.